Federated learning is quietly reshaping AI and data privacy. Let's explore what it is, how it's impacting our daily lives, and why it's a revolutionary technology. Instead of collecting all the recipes in one central cookbook, which nobody wants to do, you decide on a different approach. You all start with a basic, shared recipe. Each person bakes a batch, learns what works and what doesn't, and then only shares the lessons learned, like add more chocolate chips or bake for 2 minutes less, without ever revealing their secret ingredients. Everyone updates the shared recipe with these insights, and over time, you collectively create the ultimate cookie recipe without anyone ever having to give up their private family secrets. That, in a nutshell, is federated learning. In the world of AI, the secret recipes are our personal data stored on our devices, like our phones, laptops, or smartwatches. Traditionally, to train a smart AI model, companies would need to collect massive amounts of user data and store it on a central server. This raises huge privacy concerns. Who has access to my data? How is it being protected? We've all heard the horror stories of massive data breaches. Federated learning flips this model on its head. Instead of moving the data to the model, it moves the model to the data. The central company, let's say Google or Apple, sends a generic AI model down to your device. This model then trains locally, right there on your phone, using your data. It learns from your specific usage patterns. For example, it might learn which words you tend to type next, or what your favorite emojis are. But here's the crucial part: your personal data never leaves your device. Once the model has learned from your data, it creates a small, anonymized summary of what it learned and update. Think of this as the baking tips from our cookie example. This small update is then encrypted and sent back to the central server. Your raw data, like the actual messages you typed or the photos you looked at, stays securely on your phone. The central server then receives these small, anonymous updates from thousands or even millions of other devices. It intelligently aggregates all these updates to improve the shared, central AI model. It's like combining all the baking tips from all your friends to perfect that one master recipe. This newly improved model is then sent back down to everyone's devices, and the cycle continues. The model gets smarter and more helpful for everyone, all without any central party ever seeing your private data. This approach offers incredible advantages, with data privacy being the most obvious one. Since your sensitive information never leaves your device, the risk of it being exposed in a central server breach is eliminated. This is a massive step forward in protecting our digital lives. It also leads to better security. The communication is minimized. Only small, focused updates are sent, not entire datasets. This reduces the attack surface for anyone trying to intercept information. Furthermore, techniques like differential privacy can be applied to these updates, adding another layer of mathematical noise to make it virtually impossible to reverse engineer and figure out any individual's contribution. So, where is this amazing technology actually being used? You're probably using it every day without even realizing it. One of the most common examples is the keyboard on your smartphone. When your phone suggests the next word you're likely to type, that's often powered by federated learning. The keyboard model on your device learns from your typing habits. It sends anonymous updates back to improve the main predictive model, which is then shared with all users. This is how your keyboard gets better at predicting what you want to say, without sending your private conversations to a server. Another great example is in healthcare. Medical data is incredibly sensitive. Hospitals and research institutions hold vast amounts of patient information that could be used to train powerful AI models for diagnosing diseases, predicting patient outcomes, or discovering new treatments. However, sharing this data is extremely difficult due to strict privacy regulations like HIPAA. Federated learning provides a solution. A model can be trained across multiple hospitals without any of them having to share their confidential patient records. Each hospital trains the model on its own local data, and only the anonymized model updates are shared. This allows for collaborative research on a massive scale, accelerating medical breakthroughs while fiercely protecting patient privacy. Imagine an AI model that can detect rare diseases by learning from patient data across the entire world, without a single patient record ever leaving its home hospital. That's the power we're talking about. The tech industry is also a huge adopter. Think about a feature like Hey Siri or OK Google. To make these voice assistants better at recognizing your specific voice and accent, they need to learn from you. Federated Learning allows the model to fine-tune itself on your device using your voice commands, improving its accuracy for you personally without uploading your voice recordings to the cloud. Even in the automotive industry, Federated Learning is finding its place. Self-driving cars generate a ton of data from their sensors. To improve their driving algorithms, they need to learn from diverse and tricky road situations encountered by other cars. By using Federated Learning, a fleet of vehicles can share driving insights without transmitting huge volumes of sensitive video and sensor data, making the entire fleet smarter and safer over time. So, what's next for Federated Learning? The potential is enormous. As we connect more and more devices to the internet, the so-called Internet of Things, or IoT, Federated Learning will become even more critical. Your smart home devices, from your thermostat to your refrigerator, can become smarter and more personalized by learning from your habits without sending a constant stream of data about your home life to a central server. We could see it used in finance to detect fraudulent transactions by learning from patterns across different banks, without the banks having to share sensitive customer financial data. It could be used in retail to personalize shopping recommendations without tracking your every move across the web. The applications are truly limited only by our imagination. Of course, it's not a perfect solution for every single problem. There are still technical challenges to overcome, like managing the communication overhead with millions of devices, ensuring the updates themselves are secure, and dealing with biases that might exist in the data on different devices. But researchers are actively working on these problems, and the field is advancing rapidly. To quickly recap, Federated Learning is a decentralized approach to training AI models. It keeps raw data localized on user devices and only shares anonymous model updates. This provides huge benefits for data privacy and security. We're already seeing it in action in our smartphone keyboards, voice assistants, and in cutting-edge healthcare research. As we move into an increasingly data-driven future, technologies like Federated Learning that prioritize privacy by design are not just a nice-to-have. They are essential. It represents a fundamental shift towards a more responsible and user-centric way of building artificial intelligence. It's about getting all the benefits of smart technology without having to trade away our privacy. The future of AI is not just about making models bigger or faster. It's about making them safer, more private, and more trustworthy. And Federated Learning is a cornerstone of that future. Thank you so much for watching. I hope this gave you a clear and exciting look into the world of Federated Learning. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe and hit that notification bell so you don't miss our next deep dive into the tech that is shaping our world. Let me know in the comments if you have any questions or what other topics you'd like to see covered. Thanks again, and I'll see you in the next one.